That was section 12.4. The last time we were together, we talked about polynomials. In this particular section, we're going to be talking about polynomials some more. Specifically, how to add them and subtract them. So I'll just give you a general rule here. When adding or subtracting polynomials, we distribute any number in front of parentheses to eliminate the parentheses. And then combine like terms. We talked about like terms in our last class. Like terms just mean they have the same variable and the same variable powers. All right, so let's get to some examples. What if I asked you to add or subtract? And we had negative 2x plus 3 plus parentheses 4x squared minus 3x plus 2. The parentheses don't really matter here because there's nothing in front of them. Eventually, we're going to be doing more advanced problems where there is a number in front. I mean, we could always just put a 1 in front and distribute it. That gets rid of the parentheses. So just negative 2x plus 3 plus 4x squared minus 3x plus 2. And then we combine like terms. So we're looking for, this is the only x squared term. These are the x terms. 3 plus 2 is 5. That would be how you do something like that. Generally, the question was, does the order matter? The answer is no, it's not really right or wrong. If the order is mixed up, generally what we try to do is we always write the highest power and then in descending order, okay? So x to the second, x to the first, and then the number. What if we had 4x squared minus 3x plus 1 plus 2x squared minus 3? Distribute the 1 in front. Similar to the problem we just did. When we look for any x squared terms, the x terms Well, let's hope there's only one. And then the numbers. I've even seen them give you problems where it's like vertical on top of each other. So if you had 2x to the third plus 4x squared minus 2x plus 6, and we're adding x to the third minus 2x squared plus 5x minus 3. I've never really seen this outside of my math lab homework. But again, just like before, you add like terms. So 2x to the third plus 1x to the third is 3x to the third plus 2x squared plus 3x plus 3. About negative 2x plus 3 minus 4x squared minus 3x plus 2. This one's subtraction, really the same as before. We just distribute the numbers in front. In this case, we're distributing a negative 1. And we just get negative 2x plus 3 minus 4x squared plus 3x minus 2. And then our like terms, looks like this is the only squared term. Negative 2x plus 3x is just 1x. And then 3 minus 2 is 1. Four x squared minus 3x plus 1 minus 2x squared minus 3. And similar to before, we could put a 1 in front, distribute those numbers. This is just 4x squared minus 3x plus 1 minus 2x squared plus 3. And then we combine our like terms. So hopefully you're getting the hang of it by now. Pretty easy. The only way I can really make it harder is if I put like multiple polynomials. We'll see that in the next example. Question? You can tell if you're adding That's exactly right. I mean, if the question was, you could tell if you're adding or subtracting by looking at this sign. Really, all we're doing is we're distributing the number in front of the parentheses, and then we're just adding like terms. Does that make sense? So I don't really like thinking about it like we're adding or subtracting. We're just combining like terms after we distribute. Good question. How about 4x squared plus 2x minus 1 plus 2x squared minus 5 minus x to the third plus 3x minus 4. So just kind of piggybacking off of that question, it's not really like we're adding and we're subtracting different polynomials. We'll distribute the number in front of the parentheses. These numbers are called scalars, by the way. Just random fact. Another random fact is that honey is the only food that never goes bad. I just read a really good book, and that was in the book. I thought it was interesting. Yep. They say you learned something new. Maybe. You already knew it. So distributing all the numbers in front gives us this, and then we could just combine our like terms. So like we had suggested before, let's just keep it in the order where the highest powers come first, and then we cascade them down. So I'm going to put my x to the third first, and the sign of the x to the third is always to the left of it. So obviously this is negative x to the third. Then we have 4x squared, 2x squared, so that's 6x squared. 2x, negative 3x, and then negative 1, negative 5, and positive 4. So negative 6 plus 4 is negative 2. Let's say you do something like that. Right, a couple more things left in this section. I'll just ask you to perform the following. If I asked you to subtract 2x plus 3 from 3x squared plus 2x minus 4. If I asked you to subtract 2 from 10, what you would do is 10 minus 2, right? So when you subtract, you put that second. So this is kind of like the problems we just did, 3x squared plus 2x minus 4. So we're subtracting 2x plus 3. So we just one extra step to set it up, distribute the numbers in front. And this is 3x squared plus 2x minus 4 minus 2x minus 3. Finding like terms. I like this underline system. It just makes sure that I don't miss anything. 2x minus 2x cancels. Negative 4 minus 3 is negative 7. And then I'll give you one. This is the hardest kind of problem you'll see from this section. Is if I ask you to subtract x squared plus 3x minus 1 from the sum of x squared minus 3 and 2x squared plus 4x. You say I can copy it down. Again, we're subtracting something from something else. So that's going to go at the end. Sum means we add. So what we're doing is we're adding x squared minus 3 plus 2x squared plus 4x, and then subtracting x squared plus 3x minus 1. How that works. Distribute the numbers in front of the parentheses. And then combine our like terms. So it looks like we have an x squared minus an x squared, so those are gone. But we do have a 2x squared, so that's going to stay. So we have 2x squared. We have 4x minus 3x is 1x. And then negative 3 plus 1 is negative 2.